All right. Welcome everybody to another class, chemistry class with Ket's book. How's it going? What I want to do today is go over this pH review that you guys had to do, and then we'll talk about some new stuff for today. So just a reminder, the new stuff for today is going to be the last new stuff for this chapter. And so we are going to have a test probably next Tuesday. And I can be a little bit flexible, so I need a little heads up. If next Tuesday doesn't work, we can do it next Wednesday. But if we do it next Tuesday, then we can have just next Wednesday as a chill day where we don't do anything. So it's really up to you guys. We will be doing review on Monday, and we can have the test. I was planning for next Tuesday, but we do it Tuesday or Wednesday. Either way works. All right, so hi everybody. Let's get started here with our pH review. So some simple calculations of pH right here. We have one of these. Well, the first thing you have to do is just identify, is this an acid or a base? And the first one is an acid, we know because the H in front, and the second one is the base simply because there's no H in front, but there is an OH out here. So there are some strange looking acids and bases out there, but I won't give you them. All of my acids or bases will look like these with an H in front or an OH here whenever you're calculating pH. Now, you will have some strange looking acids and bases to find for this kind of question, but not for this kind of question. So, Anna, is there supposed to be a worksheet for 9.5? Yeah, I posted on Google Classroom, but I posted this morning, so maybe if you looked last night you didn't find it. But it should be there. I'm pretty sure. So I posted it. Yeah, I'm sure. I posted it this morning and should be. Did anybody, there's only a few guys on right now, but did anybody get it? The new worksheet? I don't know. There's no attachment. I'm pretty sure it's there. Oh, wait. No? Bummer. Okay, so I will, you know what, I can't do anything about it right now, but let's just go through this stuff and then you guys can take some notes as we go and then copy them onto your worksheet. Or you could just, because you could just take a picture. So the front side of your worksheet, you don't need to necessarily even print out. So I'll make sure to upload that because I'm pretty sure I did, but I guess maybe it didn't work out. So I'll make sure I do that right after class. Okay, so sorry about that if it's not there. So you guys are all saying it's not there. So I'll have to make sure I upload that again, okay? All right, so anyway, let's go on. All right, so let's talk about this. So we have pH of these things. If it's an acid, it's going to be negative log. So the pH is a negative log of whatever that number is, 0.0335. And if it's a base, it's going to be 14 plus the log of whatever that number is, 0.000743, because these are already molarity numbers. Okay? So your acid, negative log of 0.0335. Oops. Must have typed that in wrong. Yep. That was negative log of 0.0335. That should be 1.475. 1.475. And for pH, I'm not going to be super picky about this, but for pH, your significant figures are only the digits after the decimal point. So you might be tempted to just round it off as 1.47, but that would be incorrect. You need to have all these digits over here. And that's just got to do with the way the log works. The number out here is actually not significant. It just tells you how big or small it is. Okay, and that's going to be a bigger deal when we get down to B. So in B, it's going to be 14 plus the log of 0.000743. And that's going to get us 10.871. Yes, I know that looks like a lot of digits, but only these 3 digits over here are significant. The 10 over here is essentially like your exponent, okay? And so please make sure when you're calculating pH, please give me plenty of digits over here. So for example, if you wrote 10.87, I would give you full credit, okay? But if you write 11, let's say you write pH equals 11 for this one, that would be, I would take off points for that, okay? Because that's not telling me enough information. 11, pH of 11 is really not enough information, okay? So please make sure you include plenty of digits here for your pH calculations. Now, next one. This is a review question. So we're looking at identify acid, base, conjugate base for this. And so this is an interesting question because remember, Bronsted-Lowry theory is that an acid is an H plus donor and a base is an H plus acceptor, right? But according to Arrhenius, neither one of these is an acid or a base, right? According to Arrhenius, an acid should have an H in front, and neither one of these has an H in front, and a base should have OH minus. And so it's not too hard to follow. We follow the nitrogen, or you follow the phosphorus to see what's happening here. And when we follow the nitrogen, we see the NH3 turns into NH4 plus. So NH3 has gained an H. And it's because it's gained an H plus, that means that this is your base. Remember, a base is what gains an H plus in a Bronsted-Lowry acid-base reaction. And if this is our base, this is going to be our conjugate acid, okay? So those are your base and your conjugate acid. And then your pH3 must therefore be your acid, but let's just confirm. Let's look at the reaction. pH3 goes to pH2 minus, which means this has lost an H. And remember, the thing that loses an H is going to be your acid. So this is your acid and this is your conjugate base, okay? All right, so those are some review questions. Let's go ahead and jump into the big math questions. And I can tell you the truth, on your test, you're going to have a question like this, and you're going to have a question like one of these where you have to do this. Free response, okay? So make sure you're able to do this. But we've done, after this, today's homework, you have done so much practice that hopefully this is going to be not hard at all, okay? As long as you're actually doing the stuff, and it'll be open notes, you can go back and look at your work, should not be a problem, I hope. So 4 grams of sodium hydroxide in a 15 milliliter aqueous solution, what is the pH? For pH, you first need to calculate the molarity. So for molarity, you first need to calculate the moles, and we have grams. So what you need to do is we need to take these grams, go from grams to moles, then we take the moles, go from moles to molarity, and finally we're going to use the molarity to calculate the pH. So that's your plan of attack here. Okay, so 4 grams of NaOH. We need the molar mass because we want to convert to moles, and I already know this is about 40 or 39.99 something, but let's go ahead and calculate it anyway. Sodium hydroxide has, where is it? 1 sodium, 22.99. It has 1 oxygen, 15.999. And it has 1 hydrogen, 1.0079. So that means it's 39.997. 39.997 grams per mole. So to go from grams to moles, we need to take this 4 grams and divide by the molar mass. So that's going to be 4 divided by that number. Again, I highly recommend that you use the numbers in your calculator rather than retype them. And that's going to get me at 0.1. 0.1 moles. Okay, next we need, actually we only really have 1 significant figure from that 4, so not a lot of significant figures in this one. Next, we need to calculate the molarity. Molarity is moles over volume. Remember that volume must be in liters. And so we have 15 milliliters here, but that's not what the volume is in this equation. So let's go ahead and write down the moles. So 0.1 mole. And then our volume is 15 milliliters, but that's got to be in liters. And so we need to move that decimal point 3 spots to the left. So 1, 2, 3 means it's going to be 0.015 liters. So let's go ahead and do that. So divided by 0.015 means we have 6.667. A lot of sixes there. 6.667 moles per liter. Finally, what is the pH? Now, to calculate the pH, we need to know, is this an acid or a base? What do you guys think? Is it an acid or a base? Let's see in the comments section. Is that an acid or a base? Well, it's a hydroxide, so it, of course, is a base. And if it's a base, the pH is going to be 14 plus the log of this OH minus molarity. So we can go ahead and type that in. 14 plus the log of that previous answer. And we are going to get 14.8239. We'll just, you know what? We have really only one significant figure, so we're just going to say 14.8. It might look like 3 significant figures, but remember, when you have one significant figure, that means you need one digit after the decimal point. So 14.8 is our pH in this one. All right? And that is highly, highly basic, right? It's more than 14. Somebody may have told you before that you can't, pH is just like 0 to 14. Well, that's actually wrong. You can have a pH that's more than 14. You can have a pH that's more than 15 even, right? Or you can have a negative pH. Negative pHs are possible. Next one, number 4. 123 grams, that's a lot of hydrobromic acid. See, it looks kind of like hydrochloric acid, but this is a bromine instead of a chlorine. So hydrobromic acid. And so once again, we need to go through the steps. First, calculate the number of moles. Second, calculate the molarity. And third, use that to calculate the pH. So 123 grams of our HBr. Converting that to moles, we need the molar mass of HBr. So let's move everything up. HBr is going to be 1H and 1Br. Fairly simple. So that's 1.0079 plus bromine's right over here, right underneath chlorine, and which is underneath fluorine. Bromine is 79.904. And that gets me 80.9119. Okay? 80.9119 grams per mole. All right? So what we do is we do our 123. We're going to multiply by numbers on top, divide by numbers on the bottom. So that's going to be 123 divided by our previous answer to get me 1.52. And that's nice. 3 sig figs for that one. 1.52 moles. Okay? Now, next is we need to calculate the molarity, right? First, calculate the moles. Second, calculate the molarity. So molarity is moles over the volume. And so it's going to be 1.52 moles. We have a volume of 175 milliliters, but we need to make sure that that is in liters. So we take the decimal point, move it 1, 2, 3 spots to the left. That's going to be 0.175 liters divided by 0.175 gets me 8.67, which is fairly concentrated of this very strong acid. So 8.67 moles per liter. Finally, HBr, is that an acid or is that a base? Well, we have an H in front, so it's an acid. So our pH is going to be the negative log of our 8.67, which is, let's see, negative log of that gets me negative, and don't forget that negative sign, don't think, oh wait, negative, that must be wrong. It's not wrong. It really is negative. So negative 0.939, negative 0.939, that is our pH, okay? Very, very, very acidic. Anything with a negative pH is really, really acidic. And it is most certainly possible. These things do exist, okay? This is something that you could actually make in the lab. So highly, highly acidic. You want to stay away from something with a negative pH, but it is real. All right. With no further questions, let's just do the last one. All right. I think hopefully by now you guys are getting pretty good at this. Last one is lithium hydroxide, 850 milliliters. And so we're going to start once again with our mass, 9.5 grams, and we want to convert that into moles. So 1 mole on the top, and that's going to be lithium hydroxide. Let's see. Lithium is, so we have 1 lithium, 1 oxygen, 1 hydrogen. So that's going to be 6.941 plus 1 oxygen is 15.999 plus a hydrogen, 1.0079, gets me 23.948. 23.948 grams per mole. Okay? So let's convert that to moles. So 9.5 divided by the molar mass is 0.3967. 0.3967 moles. Yes, I know I only have 2 sig figs, but I'll just round at the end. Okay? Well, second step is to calculate the molarity. Molarity is number of moles over the volume, and that's going to be our 0.3967 moles over our volume of 850 milliliters, but we have to convert that to liters. So I'm going to take this decimal point and go 1, 2, 3 spots to the left. So that's 0.85 liters. So divided by 0.85, 0.3967 divided by 0.85, and that gets me 0.466. 0.46, and we'll just round that up to 7 moles per liter. Last of all, is this an acid or a base? Once again, this is a hydroxide, so this is a base. So pH is going to be 14 plus the log of this number, 0.467. Let's see what that is. 14 plus the log of your previous answer gives me 13.669, or let's just round that up. We have 2 sig figs, so it should be 13.67. That's our final answer there. Okay? Notice that we have fairly high pHs, so let's look at our previous answers. We have a high pH for a base, a high pH here for a base, and we have a very low pH for an acid. You can have some in-between pHs, but for right now, for the problems I give you guys, they're pretty much all going to be strong acids and strong bases, so we're not expecting too many pHs that are close to 7. They're all either going to be pretty high or pretty low for the problems I give you. So before we start the new stuff, any questions? All right, as you guys are thinking about your questions, let me just give you guys a little plug right now for our chess tournament. We're going to have another chess tournament today at 3:30 right after school, and it's going to be crazy because we're not doing a regular chess, but we're doing crazy house chess, which means anybody can play, even if you feel like you might not be as good as other people. Crazy house chess, basically the rule is that when you take a piece, you can use that piece and just put it down anywhere on the board that you want to, which makes for a very crazy game of chess, which I think is going to be fun. So if you're interested, shoot me an email, or various different students also know the link to get into the tournament. It's going to be a lot of fun. All right. So last up here, I don't see any questions. So I think you guys are doing pretty well in this. Let's get into the new stuff. So apparently the new assignment that has not been uploaded, the assignment's there, but the document hasn't been uploaded. Sorry about that, guys. I will upload it right after class, okay? But here it is. You guys can look at this assignment. We're going to go through, let's say, maybe a few of these, and then we're going to go through this. So today, it's all about acid-base neutralization and titration. All right. When is the tournament? Tournament's at 3:30 today, okay? So 3:30, right after school, and I think I sent out an email already. All right. All right, so let's check this out, guys. So here's our homework, and again, I'm going to send you guys out the assignment right after class today. So acid-base neutralization, what is this? When you have an acid and you react it with a base, the two things are going to neutralize each other, and you're going to end up with something that's less reactive than either an acid or a base. Okay? And the most classic example of an acid-base neutralization is going to be 1A here, HCl plus sodium hydroxide. So hydrochloric acid and sodium hydroxide. When they react, what happens? Well, you've already seen similar kinds of things before, but now I actually want you guys to predict the products. Rather than just identifying things, we're going to predict the products. So this is what we're going to do. We're going to say, okay, we know that this is the acid because the H is in the front. We know that this is the base because the OH minus is here, right? And so what's going to happen is the H plus is going to react with the OH minus, and you're going to get out, well, what's H plus? Let's even write it up here. H plus OH minus. What's going to happen? The H plus is going to connect with the OH minus, and they're going to turn into H2O, right? You've got two hydrogens, one oxygen. You've got a positive, you've got a negative. The positive and the negative are going to cancel each other out, and you're going to make water. And that right there is the main acid-base reaction that you're going to see. Now, yes, there are some more complicated acid-base neutralization reactions out there, but I'm not going to give them to you, okay? We're going to start with the simple ones, and this is what they're going to look like. The fundamental aspect of it is H plus and OH minus to make water, okay? All right, so let's do this. So HCl plus NaOH is going to make H2O. And what's left over? You're left with Na and Cl. So it's going to be NaCl. Now notice I didn't write ClNa, right? Why? Because I know, well, I don't just know that NaCl is salt, and so we write NaCl, but I also know that this is a positive ion, right? So Na is your cation, and Cl minus is your anion. Cations always go first. So make sure when you write this over here, you don't write, all right, if you write ClNa, that's going to be wrong, okay? And it will be marked wrong. Make sure you write NaCl, and make sure it's the correct formula. It's going to be a little bit trickier when we come down to something like B, okay? So A, that's it. That's your answer, all right? Now, before we go on to B, the question also says label the acid, the base, the conjugate acid, the conjugate base. This should be fairly straightforward for us because we've been doing this for a while, and we know that, of course, that this thing with H in front, that's going to be our acid. This is going to be our base, okay? It's not one of these complicated ones. It's straightforward, right? So your Arrhenius acid is your Bronsted-Lowry acid. Your Arrhenius base is your Bronsted-Lowry base, right? Now, but what about this side? Which one's the conjugate acid? Which one's the conjugate base? That can be a little bit tricky, but what's it going to be is, there's two ways you can think about this. First of all, when you look here and you look here, only one of these has an H. So the one with the H must be the acid, because this can't possibly be an acid. So with that logic, this must be our conjugate acid, okay? The other way to think of that is this way. The NaOH, this is your base. So the base is receiving an H+. when a base receives an H plus, when an OH minus receives an H plus, what does it turn into? It turns into H2O. And H2O, therefore, is going to be your conjugate acid. This is your base, this is your conjugate acid. Okay? And so necessarily this must be our conjugate base over here. NaCl is conjugate base. Why is that? Because HCl is losing an H plus. When the acid loses an H plus, it turns into its conjugate base. When it loses an H plus, it turns into Cl minus. And you say, well, where's the Cl minus go? The Cl minus is right here. And so on. All right. H2SO4 and NaOH. This one's a little bit trickier because you have two H's here and you have only one OH minus here. So for this one, we're going to need to do something special. That is, because we have two H's, we need two OH minuses to react with them. So we're going to have two of these to react with two of those to make what? 2 H2O. Okay? We're going to fully neutralize this acid here, get rid of both of the H's by reacting them with two OH minuses. Okay? Now, let's skip down. So C is kind of like A, but let's skip down to D to look at that for a second. Here you have H2SO4 again, but here you have barium hydroxide, which has two hydroxides. In this case, you would have two H pluses and reacting with two OH minuses, so you don't need to put a 2 in front there. You would still make two waters in this case, okay? But you don't need to put a 2 in front here because there is a 2 right there. So be careful on that. But we'll go through all this next time. I just want to go through two examples and then move on, okay? Let's look at this. What else is it going to make? So we make two waters plus what else? In addition to two waters, we have two sodiums and we have one sulfate. So the two sodiums, because sodium is a positive ion, or it's a cation, is going to be Na2, and we have SO4. All right, so I got the two. First of all, I got the 2 because I have a 2 in front here for the sodium. And secondly, why else is the Na2? Let's do it. Let's do it right up here. Okay. So we know that Na is a positive 1 charge, and we know that sulfate is SO4 2 minus. So to get the formula of the compound that they make, this 2 is going to go to the sodium, and this 1 is going to go to the sulfate. So we take those two numbers and flip them, and it becomes Na2SO4. So there's two different ways, guys, that you can get the formula of this. One way is through knowing, well, what are the different ions, all right? And you can get the formula that way. And the other way is by looking over here and saying, after I make water, what's left over? I've got two sodiums and I got one sulfate, so it must be Na2SO4. Okay? All right. Last up here, before we move on to the titration, we need to identify things. Okay? Well, H2SO4, that's our acid because it's got H in front. Sodium hydroxide is still our base. Okay? And once again, water, in all of these examples, water is going to be your conjugate acid for two reasons. First of all, because it's got an H in front, so it must be some form of acid, according to Bronsted-Lowry at least. And secondly, because we say, okay, this is our base. When the base receives an H+, it turns into H2O. And so this is your base. This must be your conjugate acid. So base, conjugate acid pair, acid, and once this acid loses its H's, it turns into what? You got your sulfate here, so this is going to be your conjugate base. Okay? All right, questions on these. Looks like most of the questions in the chat is about the homework. Apparently, I forgot to upload it, or I tried to upload it and it didn't work, so I will do that right after class. But any questions on this stuff? All right, we are going to go on to the very, very last topic before our test, and that's titration. Titration involves involves an acid-base neutralization. So you have an acid and you have a base. But in a titration, what happens is you have a known acid and you have an unknown base. Or for, let's say, for your number three here, you have a known base and you have an unknown acid. So one of the things you know, one of the things you don't know. Your acid-base titration is actually very, very useful for determining unknown concentrations or unknown molar masses. So very, very useful. And in fact, if we were in school right now, we would be doing an acid-base titration lab, but we're not. So, whatever. And because we're not in school doing an acid-base titration lab, I'm going to ask all of you guys to go and watch this other video. It's not my video. It's some other video of somebody else made on acid-base titration. I think it's like 7 minutes or something like that. So make sure you go check it out. I gave you guys the link on Google Classroom. Anyway, so acid-base titration, we have some kind of unknown and we want to figure out what it is, either its concentration or its molar mass. In all the examples I give you, we're going to be figuring out its molar mass. So in a titration, you take some unknown acid or base and you're going to completely neutralize it. So you're going to, if it's a base, you're going to react it with an acid. If it's an acid, you're going to react it with a base until you have a perfect acid-base neutralization reaction so that you have a neutral solution. And the way that you do this in the lab is with an acid-base, you could use a couple of different things, but you use an acid-base indicator. So an indicator, so acid-base indicator, which is also known as a pH indicator, right? What that thing does, it changes color. And there's a whole bunch of different ones of these. Sometimes they'll change, from, let's say, yellow to blue, or they'll change from pink to clear, or something like that. But there's a whole lot of different possibilities for these color changes. Basically, in the lab, when it changes color, you're done. And the acid-base neutralization reaction is done. And so you guys can go on and watch that video that I gave you guys on titration and check that out. And you'll see, essentially, when the color changes, it's done. There's another way to do this, and that's with a pH meter or a pH probe. And that pH probe will give you a number and tell you what the pH is. So that's the other way. All right, so that's all kind of the background information. Let's look at the problem itself. Let's suppose we titrate an unknown base with a certain amount of known acid. We're going to dissolve this base in water, and it requires a certain amount of acid to reach the equivalence point. So this is kind of like a stoichiometry problem for acid-base neutralization reactions. But the way we're going to solve these is all going to be relatively straightforward, and it's all going to be exactly the same way. What we're going to do is we're going to take this volume and multiply it by the molarity to get the number of moles. Well, how is that? So we have molarity is N over V, and we want the number of moles. Why? Why do we want the number of moles? Because we want to get the number of moles of your unknown base in order to figure out the molar mass. All right? We're going to see how this works here in a minute. Okay? So you have this calculation, M equals N over V, but we want to calculate N, so we're going to multiply both sides of the equation by V, so N equals Vm. Okay? And what we're going to do first, and always we're going to do this first, is we're going to use these two numbers of the known. This and this. That's our known stuff, the thing that we're using to titrate with, right? Because the unknowns, we can't start with the unknown because we don't know enough about it. So we're going to calculate how much known acid are we adding to reach this equivalence point. The equivalence point is basically when the color changes. Okay? So let's go ahead and do the math. So your N is going to equal your volume. Now, remember, milliliters need to be in what, this volume needs to be in what units? It needs to be not in milliliters, but in liters, because your molarity is in moles per liter. So we need to make sure we convert that volume to liters, just like we've been doing for all the other problems. So we're going to take that decimal point, move it 1, 2, 3 spots to the left. That's going to be 0.0372 liters. That's our volume. And your molarity is essentially like a conversion factor. So we have 0.1 molar or 0.1 moles per liter HCl. So it's going to be 0.1 moles per liter. I'll just move that decimal point. That's going to be 0.00372 moles. Okay? That's your first step. Next step. Well, we got to think about what this means first. For your next step, this is the number of moles of acid that we added. But the key to this titration thing, well, what's so special about this, is that this is the moles of acid, of known acid, but it's also equal to the moles of unknown base. So we use this known to figure out amount of unknown. So the moles of acid are equal to the moles of your unknown base. And once you know that, well, now we can calculate the molar mass. How do we do that? Molar mass is simply going to be your mass divided by your moles. It's going to be what is the mass of 1 mole of your substance. So it's the mass. And what mass? We look back in the problem, we find, all right, we're dissolving 0.5 grams of this unknown. So your mass of your unknown is 0.5 grams. And the moles of your unknown are 0.00372 moles. And when you do the mass divided by the moles, it's going to get you the molar mass of your unknown. All right, let's do it. So we have 0.5 divided by 0.00372 gets us 134.4. We have only 3 significant figures. We're going to round it off to 134. 134. And the units are grams per mole. Okay? That is how to solve a titration problem. And it's really, really unfortunate, guys, that we can't actually do this in the lab. So sorry about that, but we're still going to do these calculations. You guys have the second page to do for homework where you have 2 more sample problems like this. But let's just go ahead and pause there. And we only have a few minutes left of class. Let's see, do you guys have any questions? All right, so information on Google Classroom. Google Classroom, basically schools set that up. So that's not something that, like my Google Classroom is not a public thing. It's basically different schools set it up for putting all of their classroom announcements and their assignments up on. So it's, you can just look up Google. It's in the Google suite of stuff. You could do it yourself. If you're a teacher, anybody can do it. It's free. Anyway, any questions at all about this? As you're thinking of your questions, one last time, I'm going to give you guys a plug. Chess tournament today, 3:30, right after school, 3:30, chess.com. Make sure that you guys go in there and join our tournament. It's going to be a blast. Crazy house tournament. Crazy house rules. All right, all good? Good. So I'm going to go ahead and sign out. There's a back. Yes, there's a back. There's a second page, and that's going to be, it's going to be this. So these 2 problems. Essentially, you have 2 problems which are just like this problem that we solved, and then you also have to do these. Right now, I'm going to sign out, and I'm going to go upload to Google Classroom. Sorry about that one last time. But if there are no further questions, we're going to sign out. All right? See you guys.